All right, so this is an accelerated ion problem. First off, right, so the electron's accelerated in a television tube but through 5,500 volts, right? So we know that the 5,500 volts, so 5,500 joules per coulomb times 1.602 coulombs, that's the charge on the electron, right? This will give us the kinetic energy of these electrons, right? And from that we can figure out the velocity. So let's do that first. 5,500 times 1, because this is what we're going to do. We're going to figure out this velocity. We're going to figure out the electric field this way. We're going to figure out the acceleration of it this way. The time it spends between the plates using projectile motion, basically, right? And knowing that time and knowing the acceleration, we can figure out, we'll know its velocity this way, we'll know its velocity that way, right? And then the angle will be the angle between those, the horizontal velocity, which I'm about to calculate, and the velocity it got while it was accelerating this way, right? Okay, but baby steps, here we go. Okay. So let's figure out the velocity of our electron. So this potential energy, 1.602 E minus 19, I'm going to store that in A. And that's 8.811 E minus 16 joules, right? And then that equals 1/2 mv squared of the electron, right? So 9.11 E minus 31. That, you can look that up in the data packet, right? Times v squared. So let's figure out the velocity of the electron. All right, here we go. Let's go to square root of 2 times the answer I just got, divided by 9.11 E minus 31. Okay, storage B. Okay, now very unhelpfully, it gives me 4398133.2289. All right, so now we know the velocity that's going this way, and now we can set up our x and our y directions, right? Okay. Okay, so in the x direction here, they're 6.5 centimeters long. So 0.065. The velocity is, okay, I just have to put that in scientific notation because it just bugs me. Pet peeve. All right, let's exit. Let's go second answer. So 4.398 times 10 to the 7th meters per second. So this is good. We don't have a velocity that's anywhere close to the speed of light, which is 3 times 10 to the 8th. That becomes problematic. 398. There's nothing accelerating it anymore, right, in this region, so the final is the same, right? This is 0, right? And then let's figure out the acceleration of it in the vertical direction. Okay, let's see. In the vertical direction, let's figure out the electric field. The electric field is voltage divided by distance, right? So 250 divided by 0.013. 250 divided by 0.013. And that's 1.923 times 10 to the 4th volts per meter, or newtons per coulomb, right? Okay, so therefore the force is going to be EQ, right? The force is going to be EQ, and so 1.923 e to the 4th, and then it's an electron, right? So it's 1.602 minus 19th. Okay, so times, oh wait, I'm going to store that in C. Okay, so times 1.602 e minus 19. And I get that it's 3.08076 times 10 to the minus 15th newtons, right? And then the acceleration is F over m, right? whatever, divided by, and then a mass of an electron is 9.11 minus 31. So divided by, we're almost there, man. Wow, that's a lot of acceleration, right? So you know, some people will say, well, do we ignore the acceleration of gravity? Well, let's just see. The acceleration I'm getting is 3.3817. Okay, and I'm going to store that in D just for fun. 3.3817 times 10 to the 15th meters per second squared. Right, and that is, of course, up. It's an electron, so it's a negative charge. It would be attracted upwards, right? Okay. Now, here's what you're going to do. You're going to go use S is ut. Just like projectile motion, right? Solve, find the t. T is going to go across, right? Okay, and then all we really care about, by the way, is what this v is. We're not actually trying to figure out this displacement, although we could figure out that displacement, right? But ultimately, we want to solve for, and this initial velocity we'll say is 0, right? You want to solve for this guy. So it's basically going to be this times that time is this, right? Once you have that, once you have this velocity and this velocity, you're going to draw a little picture of this thing, right? This is going to be your 4.398 E7. This will be the answer that you got from here, right? Okay, and then to find that angle, you're going to go inverse tangent of this over this. All right, happy hunting.